Okay, in this second video, dealing with evaluating limits numerically using a graphing calculator, we'll go on to example 3 in this set here, and we'll start by putting the expression into the calculator. We'll need to use parentheses for the numerator, square root of x plus 6, close parentheses on the square root, minus square root of 6. Again, close parentheses on the square root, close parentheses on the whole numerator, divided by x. And we go to check to make sure that we are in independent ask mode on table set. So go second, table set, and it is set to independent ask. We'll go over next to second and table, and we'll put in the values for problem 3. So we have negative 0.1, and we came up with 0.20498. Now I just happened to use 5 decimal places there, whereas above I used 4. It doesn't really matter since it's hard for me to tell exactly where this is going just yet. So next one, negative 0.01, and we get 0.20421. Okay, still, it looks like we're heading for 0.204, not exactly sure. We'll keep going another, negative 0.001. And that brings us to 0.20413. Now, we seem to be slowing down. I don't think we're going to go all the way down to 0.20. It looks like we're heading for 0.2041 something or other. And even though the table doesn't ask for it, I'm going to go ahead and put in another value or two, negative 0.0001. And we see that it's at 0.20412 there. So I'm going to assume that that's the limit that we're heading for. There are other decimal places there. We only see that much of it. It's actually 0.204124. And if we wanted to, we could continue to put in smaller and smaller values approaching 0 from the left. We'll go ahead and try one more. Negative 0.123441. And again, you can see we have 0.20412, and I think that that's going to be sufficient. I believe that that's the limit that we're looking for there. We'll try some values approaching from the right, so we'll go back up to the top, and we'll do the same values, only positive this time. And we get 0.20328, and remember we put this all the way over to the right, and then we'll put in 0.001, and we get 0.20412 right away there. And we'll go next for 0.001, and then we're still at 0.20412. And we're going to settle on that value as the limit, even though the actual limit may be 0.20412 or 2. We really don't know, but we're down to 5 decimal places. It's not going to go beyond 0.20412, so that should be safe. And so we record the limit value. Now, what I do want to point out here very briefly is if you look at the difference between problem 1 and problem 3. Problem 1, we're approaching x equals 4. And so we go 3.9, 3.99, 3.999, and from the right 4.1, 4.01, 4.001. But in problem 3, we're approaching 0, and so the numbers that we choose are slightly different. From the right, we're still going to do 0.1, 0.01, 0.001, etc. But from the left, because we're approaching 0, we're also going to use negative 0.1, negative 0.01, negative 0.001. So please note the difference between problem 1 and problem 4. When we approach a number other than 0, we're going to do it 0.99999, etc. from the left, 0.1, 0.01, 0.001 from the right. But when we're approaching 0, it's going to be 0.1, 0.01, 0.01 negative, and 0.1, 0.01, 0.01 positive. So I hope that makes sense.